The plan for today. Review. So I'll start with questions from you guys. If you guys have stuff you want to talk about. Yeah. That's my plan.
I just wanted to take the quiz.
Huh?
I just wanted to take the quiz and see what it was.
Oh. Yeah, like what you got?
Like convert series and simplification to expanded form.
Okay. So let me find a. I'll just grab that, I guess. All right. So
I have it. I just don't want
So this is like just an example of something in sigma notation. If I wanted to expand that, all I'm going to be doing is plugging the numbers 0 through 13 in for k and like putting a plus sign in between them. So like that would be the first term in my sequence, or my series, excuse me. That'd be like the second term in my sequence, or my series. And then the next one. And then dot, dot, dot. I'm not writing them all out. Depending on the directions you might, but I don't think I'd have something with 14 terms in it to write out. But that's how you go from a sigma notation to like a series in expanded form. That's not at all the directions for this problem, but I saw a sigma and I just grabbed it. I was like, okay, if you're asking about that, that's easy enough. This one will work. Yep. Yeah, it wouldn't be something with 13 terms. You'd actually write them all out, but it, like 3 to 6 is probably in the range of things that I would deem not super annoying. Yeah.
I'm sorry. In like 3.1, when it like gives you the equation, it's like a or an minus 1 or something, and then you have to find
Okay, you kind of trailed off at the end and between the open door and the trailing off. I couldn't catch the end of what you just asked. Can you give it to me one more time?
like when you're given the equation like a and minus 1, and then you have to find the 50th.
Yeah, that I am convinced that the textbook didn't edit themselves appropriately, because that's like a wholly inappropriate question to ask. Somebody else asked about, I don't remember if it was this class or the other class, but you're talking about like these guys, right?
Yeah.
And now some of these I think are like reasonable to do, even if I ask you for the 50th term, because this one you should recognize as geometric, right? Where the R is 3 and the first term is 2. So you can just do that and then plug 50 in and bingo, bango, bongo. This, because it's got multiplication and addition, is neither arithmetic nor geometric. There's no way to do it other than brute force. Well, there is, but like no way for you guys to have done it other than brute force, which I think is just stupid. Like a big fat waste of your time. I mean, like, if you were to do it in practice, this is what I would do. I would be like, okay, answer 3, 2 times that previous answer plus 5. So this is term 2, 3, 4, 5, 6, and I'm just counting to 50, which is like, seems like such a colossal waste of your time. I don't know how else they would have expected you to do it other than just like brute force it out. But why 50? Like, you could have accomplished the same thing with like 10 and not been like so tedious. But that's the gist of it. You know, like this one maybe you should recognize as arithmetic, where this is the D. So again, you could do like, you know, and then plug 50 in, and those aren't bad. Like, that's totally doable, like not super annoying. There seems like there's a skeleton key to like not have to brute force 50 of these things out. But E and F, it's an entirely stupid exercise in brute forcery. Joey.
So it says 5 choices between, just plugging 1 and 50.
It says the first 5 terms in the 50th.
Oh,
So you'd plug in like 1 through 1, 2, 3, 4, 5,
and
and then 50. Yeah, that's all you need to do. Does that sound okay? And again, if you're gonna like E and F, where you have to brute force them, where you have to build them off the previous answer, like you're gonna get the first 5 on your way to 50 anyway. But like, ugh. Those would be ones I would have just skipped as a student. I've been like, I'll give you the first 5, but I'm not doing this all the way out to 50. That seems just obnoxious. Yeah.
Are we gonna get our quizzes back?
I mean, I hadn't planned on it because there's like 5 people between the 2 classes that haven't taken them yet. But by and large, they were good. You know, like minor mistakes only. You know, there's no like big, ooh boy, Z's on there. Is that satisfactory? Okay. If you want to look at yours, I can show you yours at some other time than right now. How about problem like number 2 here? You know, can we do this one? What do you think? Can we find the common ratio? Since you're told it's geometric, you can just take one term and divide it by its previous. Notice that if I multiply like 9 over 2 by negative 3 over 2, I do get negative 27 over 4, right? Is everybody okay there? So if this is term 1, this is term 2, 3, 4. What is this one over here? Yeah. How am I going to solve for it? Yeah. So I'm going to write my general form for a geometric sequence. Set it equal to that guy. So far, so good. Now what do I do? Okay. Now what? There's something going on here that algebraically is going to make this difficult to solve for. No square roots. But look at this equation. What's going on here that's going to make this equation difficult to solve for? Not the exponent. Well, I mean, even if you knew what to do algebraically to solve for it, there's something in here complicating things. It's that guy. Because what are we going to want to use to solve this with? How do you solve for an exponent in an equation? You need a logarithm. Can you do a logarithm of a negative number? No. So these negatives are going to be a problem. The trick is you just pretend they're not there. You just got to remember to deal with it later on. We're just going to do a little pretend. Okay. So far, so good. Now, what logarithm do you want to do to both sides of this equation? Log base 3/2. So those cancel each other out. So n minus 1 is going to equal log base 3/2 of that fraction. How do I do that on my calculator? That's a calculator problem, no doubt, right? So how do I get that base 3/2 attached to my logarithm? So you got to do the math button. And you scroll down to the bottom and you want that log base command.
Are we going to do this exactly like our test?
Probably. So what do I get there? N minus 1 equals 11. So n is 12. Does that feel okay, guys? Yes.
So we just got the ratio by dividing the first, the second term by the first.
Yeah, because it told me it was geometric. So any consecutive pair of terms, if you divide the later one by the earlier one, it'll give you the same r. So I just did 2 divided by 1. Second term divided by first term. All right. So now to find the sum of that series, I can do my formula, right? Which is the first term times the fraction 1 over r to the n divided by 1 minus r. Just Double check that that's to the n and not n minus 1 or something. I don't think it is, though. No. Okay, good. It's not. So I just do that. And that's just a calculator problem, right? So that's what I got. Is that okay? So my formula for a geometric series is that. It is different for arithmetic, yes. Yeah. No, those will be given to you. Mm-hmm. Why don't you guys try for me to do number C? Okay. Take out your calculator. Write down something on a separate sheet of paper. Let's try to do C right now. Yeah. Yeah, because there's a radical in it. You have to do it by hand.
I think you can do it.
What do you think?
We do one of these columns for the rotating sequences, yeah. Briefly find the sum of the curves.
Sure. How are we doing on 2C, you guys?
Almost done.
Okay. I have answers written out if you want to check as you're kind of picking your way through it. next up, we're going to do 1D. If you're done and you want to start moving ahead, we're going to do 1D here, I guess, together by request. So I'm going to start working on that.
I'm gonna have to do this arithmetic.
That's what we're doing right now. We're going to do 1D. AN is the last term. Yep, that you're adding up. Lessa, much easier problem, right?
Yeah.
The algebra is way simpler. We'd prefer to do this one than the geometric one because you don't have to get a log or anything involved, and like there's no solving issues like when the other one where we ran into like the negative r. Sometimes that can be a problem where we just have to like kind of ignore it. Here, that never happens because all you're doing is adding, subtracting, multiplying, dividing. So negatives, no biggie.
Yeah.
So this one is all time.
How did that one feel, though? Everybody's okay there? You still kind of grinding, or do you need a minute? We ready to move on to something else? Let's do. Oops. This looks like kind of a fun problem. Let's do this. Okay, good. That's the first thing you'd want to do is identify the type of series involved. That's good. And then we're looking for when is SN greater than 678, right? Agreed? Okay, well, since SN is arithmetic, I know that's going to be A1 plus AN divided by 2 times N. And I know what A1 is. And I can rewrite AN in terms of A1 and N's. So if I do that, I can say that, right? Where 17 is just my first term, and the equation 3n plus 14 is an. It's now just written in terms of n, because that's what we're looking to solve for. When it asks how many terms, we want to know the n. So far, so good? Okay. I'm going to combine some like terms then. So 17 plus 14 is 31. And then I'm going to distribute that n through. Is everybody okay there? What I'm left with now is a quadratic inequality. To solve that quadratic inequality, I'm going to start by getting rid of the fraction. I'm just going to multiply both sides by 2. I think that's right. Somebody with a calculator handy, double check that 678 times 1356 is indeed, or times 2 is indeed 1356. If you would for me. Good. Okay. So what I'm going to do then is I'm going to subtract everything onto one side. And now I know that this guy is quadratic, so it looks like a parabola. And that parabola opens up, right? So the places where that's greater than 0 is going to be less than, this x-intercept or greater than that x-intercept. Does that feel okay? Now I'm suspecting that one of these x-intercepts is going to be a negative number, in which case I know that's an invalid value for n. The other one's going to be a positive, which is the one that I'm going to be searching for. How am I going to find those x-intercepts? I don't want to use my calculator. What if you have to do it by hand? Quadratic formula, yeah. So we know that n is going to equal b plus or minus square root b, or negative b, plus or minus square root b squared minus 4ac all over 2a. Okay, so we'll go ahead and enter these into the calculator. So one answer is 16.7. And if I change that plus to a minus, the answer is negative 27.05-ish. Well, this one's clearly out, right? So I know that n has to be greater than 16.7. So really, n greater than or equal to 17, because I know those n's have to be whole numbers. And if it needs to exceed 678, I need to make sure I'm rounding up regardless of what the decimal was on that n. Even if it was 16.1, I would need to round up to 17. You guys understand? You get why I'm saying you need to round up regardless of what the decimal was? Because if you round it down, you'll get a value less than 678, right? At 16 point whatever, it's 678 on the nose. If it has to exceed, you have to round up, because we know that decimals are no bueno, right? You can't have a decimal number of terms. It's a whole number only. Does that feel okay on how I did that? Recognizing the setup was probably the most difficult spot. If you could get to here, it's not too bad after that point. That's the trickiest piece, is realizing that I'm going to put in the general term for, or the explicit formula for an, and then end up with a quadratic where I have to solve for n. Does that feel okay there? And what I did there? It's all right. Let's do this one I thought was kind of tricky. Just grabbing stuff from the homework. What's up? 3.4, where we're doing some of them right now, which is awful nice. Okay. So here it says the sum of the first n terms of an arithmetic sequence is given by 6n plus n squared. It says write down the value of S1 and S2. How do I find S1? Yeah, I'm just plugging 1 into that formula. And then how do I find S2? Shocker of the century, right? Everybody's okay with that? Part B then says, let UN be the arithmetic sequence that we're talking about. It says show that U2 is equal to 9. Well, S1 is just the sum of the first one term, right? So what is the first term got to be? 7. S2 is the sum of the first two terms. If I know the first term is 7, and the whole thing adds up to 16, if I subtract 7 from both sides, second term is definitely 9. So when it says show that, we're expecting work. There's the work I've shown. Does that feel okay? Pretty easy, right? But you had to recognize like what S1 and S2 were telling me. A very common IB format where like your answer to part A is helpful in doing part B. Not always is that the case, but not uncommon. Find the common difference of the sequence. Well, I know that my sequence starts at 7 and then goes 9. What's the common difference then? Just 2. Then it asks for U10. Now I could do that manually, but I don't want to do that. Instead, I'm just going to write my general or my explicit formula. And then I'm going to plug 10 into that. Then it says find the lowest value for n in which u sub n is greater than 100. So just like we did in the previous problem, but this is even easier because it's asking for u sub n, not s sub n. So all I need is that explicit formula. And we'll just solve for n. And again, we got to round up to the nearest integer since it was exceeding 100. So 43 would be the first term that exceeds 100. And then it says, part F, there is a value for n, which u sub 1 plus u sub 2 plus u sub n equals 1512. Asks us to find that value for n. What does this sound just like? It sounds just like this problem, except it's going to be easier because it's going to come out to be the quadratic will just give me the integer solution to it. So if I add the 7 and 5, that gives me 12. If I divide the whole thing by 2, it'll give me n plus 6. And if I distribute the n through, so I can subtract the 1512 from both sides. Then I can solve this. It is factorable, but Lord help me, I'm not going to try to find the two things that multiply to give me negative 1,512 and add to give me positive 6. Feels like I could be here for a while. I'm just going to use the quadratic formula again. Is everybody okay with that plan? So we get 36. I know the other one's going to give me a negative value. So I'm good. What do you guys think on that? It's okay? Do you want to go over how to do some calculator stuff again? Yeah.
I think when we did 3.4, you do like the stupid limitation stuff.
Yep. That's amongst the calculator stuff that I would go over.
Yeah.
Do you want to see it again?
What would that fall?
Well, that's just like computing the sums of a series or whatever. Let's look here. So finding the value of the sum of the first whatever terms of the given sequence. So this is an example of something that we can do right in our calculator. As an aside, what type of sequence are we adding up here? Is this arithmetic or geometric? Good. How could you tell? Well, it looks like mx plus b, right? So I'm just looking at the formula inside. So to do this, I could do that, use that equation that we've been using, or I can just do the summation command on my calculator. So in place of k's, I'm just going to use x's. And I'm just going to type this in exactly like it looks like on my sheet of paper. And then press enter. Bloop. Done. If you wanted to do it by hand, if we call this guy a sub n, we'd need a sub 0. And we need a sub 11. So I would do 3 plus 5.2 divided by 2 times 12, because there's 12 terms here, because we started at 0 instead of. But that should give me that same 49.2. You could do it that way also, not wrong. Joey?
Give an example of using a geometric sequence to do finance.
Yeah, but we're not actually going to use a geometric sequence to do any of this stuff. Oops. So I don't know, I just grabbed one from the homework here. So to do any of these types of problems, what are we going to use? We're going to be using the Finance app. So you press the Apps button there in purple on your calculator. Pick the Finance option. We're going to do the TVM solver. So N is the number of payments. We're doing 10 years and we're paying every month. So my N should be 10 times 12. It says the interest rate is 5%. Notice there's a percentage sign next to the I. It requires that in 5%. It's asking us the initial value for the loan. So that's going to be the PV, the present value. That's what we're solving for. It says we're paying $450, so I'm going to make that negative $450. The future value is going to be 0 because we want to pay our loan down till it's all paid back, right? So we have some money that we borrowed that we're now in debt for, and we're paying that down to 0. And then payments per year and compounds per year are both 12 because we're paying every month and it's compounding every month. So to get my answer, I'm going to go back to present value and press alpha and enter. So it looks like I initially borrowed $42,426.61. It's a weird quantity to borrow. Maybe I was buying a car and that's what it came out to with the taxes and fees and everything. Does that feel okay? You can always do it with the TVM solver. Yeah, you can do it this way too. So it says, how long would it take to repay the loan if it's $900 per month? So I'm just going to change the 450 to 900. And this time we're going to find the new N. So that's 52 payments. So like 4 years and 5 months or something. So 52 months or 53 months. Joey?
First N is like the time.
N is the number of payments. So if you're paying for 10 years every month, that's 120 payments. So you got to think about it that way. It's not necessarily time. It's like the number of payments or the number of compoundings or whatever. Does that feel okay? Here, we'll do another one. So each month, Maxine invests 150 pounds in a fund for her retirement. The fund earns 6% annual interest compounded monthly. Find the value of her retirement fund in 30 years. So my N is going to be 30 years, but we're doing it every month, so 30 times 12. Interest rate percentage is 6%. I start out with zero money in my account, right? And then we're paying in $150. And the compounds per year and payments per year, both 12 still. And the future value is what I'm looking for. So alpha, enter. And I'll have $150,677.26 at retirement. Might want to save a little bit more. What if we up that to $200? Just do the same thing and alpha, enter. Now we have $200,903.01. Yes. Yeah, do you have a negative? If you don't have a negative on your payment, your future value will come out negative. If it's positive $200, because that's like what it's saying then is the flow is saying you're gaining $200 in. So in the future you're going to owe, right? As opposed to like the negative $200, that's coming out of your pocket. And in the future, you're going to have a big positive sum come back in. So, like, don't worry about the signage. Like, it doesn't really matter. But, like, that's why the signs are coming out the way they are, because it's indicating where that money is flowing, whether it's into your pocket or out of your pocket. So negative is out, positive is in. Does that?
Yeah.
Okay. So, I don't know, just like different variations of the same kind of thing. Say that. Find the monthly payment required to save $4,000 while earning 4% annual interest compounded monthly. And we want to do that within 5 years. So the N is going to be 5 times 12. We have 5 years, and we're going to do this every month. We're told 4% interest. I'm going to assume we have $0 presently, and we want to have $4,000 in the future, and we want to figure out what that payment needs to be. So we'll do alpha, enter. So basically $60.33 or so. Is this feeling okay on how to use this thing? It's super nice. Like, you don't have to muck around with any equations or anything. Like, you just, like, put the thing in and let it rip or whatever, and it's pretty nice. Like, once you've got it. Joey, what's up?
Can you just do one example of currency exchange?
Sure. Why not? Okay. Arthur lives in London. On August 1st, 2008, Arthur paid 37,500 euros for a new car from Germany. The price of the same car in London was 34,075 British pounds. The exchange rate on August 1st was €1 is equal to 0.7234 British pounds. Calculate in British pounds the price Arthur paid for the car. So we have 3,750 euro. And I know that €1 is 0.7234 British pounds. So I'm just going to do like a unit conversion a la chemistry, where I want like the units to match up diagonally, so when I multiply they cancel. So whatever that comes out to be, oops, get out of there. 37500 times 0.7234. So 27,127.5. Write down in GBP the amount of money Arthur saved by buying the car in Germany. Well, the car in London price minus the car in Germany price was 3475 minus 27127.5. So he saved a whole heap of money there. So 6,947.5 pounds. And then it says, on August 1st, 2008, Arthur invests the money he saved in a bank that paid 4.5% simple interest. That word's key there. Calculate in pounds the value of his interest 4 years later. So simple interest is equal to the principal plus the interest times time times principal. So this plus 0.045 times 4 years times that value. Oops, that's a 47, not 75. So what do we end up with? He's now got $8,198.50 or something. Nope, 5 cents. Well, not cents, I don't know, whatever those things are called in pounds.
How do you have the P or the other ingredients?
Well, he said he's taking that money and he's investing it, right? So that's your principal, whatever he saved. And then the I was told to me in the problem, right? That's the interest rate. And the time, well, that was told to me in the problem too. It was like basically 4 years, because it was 4 years later, right? Because we started on the 2008 and we're ending in 2012. But it's basically the simple interest is you're just earning the same amount of interest every year. You're earning 4.5% on that money. So you're basically earning this much every year. You do that 4 years in a row, and then you add it back to what you started with. That's how much is in the account now. You know what I mean? So your interest that you earned was this $12.50, and you just add that back to the amount you invested. It's not compounding, so it's not like your interest that you earned in year one isn't now part of the interest you're earning in year two. because it's simple, which is dumb. Nobody pays simple interest. It doesn't exist. The other typo, I'm sorry,
The other type of interest.
compound?
Yeah.
Yeah. I mean, that's easy though, because I just go to the TMV solver and let it do the problem for me. So if it's just annual, and it's just 4 because it's happening every year, 4.5, there's no monthly going on. The initial value is this 6947.5. No payments are happening. The future value is what we're going to be looking for, but the compounding per year is just happening once, and there's one payment per year. So I'm just going to do alpha, enter here, and there's the compound interest. That's the value if I compounded it, which is a little bit more than if the simple. Does that feel okay, Grace? So again, like if it's compound, I'm not gonna, I mean, you could do it by hand, like it's not wrong to do it, but like, no thank you, I'll pass. I'm just gonna use the TMV solver because, boy, that's easy. You just input the values. I don't have to muck around with parentheses or fraction bars or anything, you know, like it just, I know how to enter the stuff in and just let it spit it out for me. And notice here, I guess technically I would have, my signs are goofed up. My present value should have probably been a negative, because technically that money is coming out of my pocket and going into the bank. So like in the future, when I recover that money back, it'd be a positive value coming back into my pocket. But like, who cares about the signs? Like, just the number. The sign is always positive. Just the answer's positive. You know what I mean? We're not doing accounting work here. Not in this class. Maybe if you're in accounting, you're doing accounting work, and then you care about whether cash flows are positive and negative, but that's not what we're doing here. That's about the gist of it for the calculator stuff, though. Like, that TVM solver is a beautiful tool. The IB knows it, you have it. They expect you to use it. They want you to use it. It's cool. Thank you very much. I'm happy to have it. Makes doing these problems so much simpler and quicker than it would be to do it by hand. There's formulas for all this stuff, for annuities and compound interest and stuff, but like, I think they're probably on the equation sheet for your test, but like, I wouldn't, you know, I just use the solver and let it, you know, let it do what it does. We just got like 5 minutes left or so here. Does that, you guys feel pretty good about the stuffs, what to do? I think we did like the hardest kinds of problems here in the, not even sure all the hardest of the things that we did today in class are really probably harder than what you'll see on the test. You know, like for the most part, you guys did pretty well on the quiz. I wouldn't worry too much about this thing. Make sure you're comfortable with some of the series stuff, but it's basically just using formulas. You just have to understand like what it is you're doing, like what these things can do, but like the algebra and stuff is really pretty straightforward. You know, you're just plugging stuff in basically. And again, your best preparation is just like go through and try to do the homeworks, you know, or at least until they're becoming like stupidly repetitive, right? At a point, the homework is just like, okay, like another of these, huh? You know, like, but I would do some homeworks. You know, don't be afraid if you're like quite convinced the answer is correct and the back of the book says it's not, because we've seen over and over the editing in this book is, I would call substandard. That's being polite. I think it's much worse than that. It's as bad of an edited book as I've ever seen in my entire time teaching. But it's what happens when the IB like announces the new curriculum change, in like, November, and expects it to be in place, for the following school year, and somebody's got to churn a textbook out inside of, 6 months to get it to the printer so they can start printing books that they can sell in the fall. This is what you get. You don't get all the editing you probably deserve. Or the people doing the editing aren't the authors and don't think to go back and check like simple stuff like, what are we really trying to do here? It's like, oh, dear God, no, you can't do, like, that's not a problem we should be asking right now. Like, why would you do that? At least without some more like context of like, notice that this is not arithmetic or geometric, this recursive sequence I've just given you. However, we can still find the 50th term just by, but we have to do, all 49 before it to get to it. That's kind of a hassle. Like this is how you could do it on your calculator. Now, if it is arithmetic or geometric, we can resolve this into it, like convert it to an explicit formula and just plug in 50 and be done, which I think is probably what the point was when they built that question, but they did such a poor job of like letting you know that like, I know that this is a hassle because it's not this or that or the other. And there's no shortcut to do, you have no shortcut to do it. I mean, there's shortcuts to do it, but it's like well beyond the scope of this class. It's like graduate level mathematics to write a recurrence relation, to like come up with an explicit formula for something like that. That's not a trivial thing to do. At one point, Mr. Kulik knew how to do that. It's been too long and he's since forgotten, would have to review how to do that again. But it's not easy. But there's ways to do that, but it's like not what we have to be worrying about right now. So yeah, this will close up sequences and series for us. We start calculus here. We have a 3-chapter run of calculus next. Don't worry, it's like hand-picked the easiest parts of calculus that we could possibly do. So like it's not too bad. And I'll present it to you in like a very matter of fact, like this is all you need to know and this is all we have to do with this to do it. So don't let the C word scare you off too much there. But it's the stuff that you're going to be asked to do is pretty easy. And there's no memorization, again, because that way you get formulas for everything. So like, we're not going to get too complicated here. One differentiation rule, one integration rule, that's it. You don't have to worry about a million other things like you would if you're an AP and have to memorize everything, because your equation sheet for the AP calculus exam is a blank sheet of paper. Like it all must be memorized. And they expect that like any prior learnings are all memorized, like the unit circle or the quadratic formula or any rules of exponents or any properties of logarithms. Like all of it just has to be memorized. We're not giving you anything. Maybe in a story problem you might get like a geometric formula, like the volume of a cone they might tell you in a story problem. But like that's about it. It's a fun time. I know you're all jealous that you didn't take that class.